Hello, beautiful people. The first thing I would like for you to do, please, is if you have not done this warm-up, take a moment, press pause, and then come back and check your answers with mine. Thank you. All right, check your answers with mine. Make sure that we are completely matched up. Probably could have used foil for any or all of these if you wanted to. But some things I want to make sure that you see is that these are special patterns, and we are going to use them. So whether you use the box or if you use foil to do these ones, these are special patterns we're going to use today. Another thing I would just want to remind you guys of is perfect cubes. So like 1 cubed, 1 times 1 times 1 is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. ... Those are some common ones we're going to need. Squares, remember, follow the pattern. 1 squared is 1. 2 squared is 4. 9, 16, 25, 36, ... So keep those in mind as well as we do these, because we're going to simplify some of these a little bit more. So today, our SWABAT for 6.3 is to add and subtract radical expressions. So looking at the first one, first thing I want to do here is look for perfect squares, because these are square roots. And the perfect square that I see that goes into 28 is 4. That's the biggest one. 4 times 7 gives me 28, minus the square root of perfect square that goes into 64 is 9. So of that list that we made, 9 is the biggest number. 9 times 7. And then I'm going to pull out my perfect square. So the square root of 4 is 2. And I still have a 7 on the inside. Minus the square root of 9 is 3. Radical 7. Now, these are like terms because they both have the same number under the radical. So what's 2 minus 3 is negative 1 radical 7, or just negative radical x. This is like if I were to ask you what's 2x minus 3x. Oh, of course, it's negative x. And so I wrote negative x. Just kidding. Negative radical 7. There you go. All right, let's try another one. It's a little bit different from what we've done before, is that now we have perfect cubes is what we're looking for. So remember that list we just made. I want to find the biggest perfect cube that goes into, first of all, 81. So looking at that list, the biggest perfect cube that I see is 27 times 3. 27 times 3 is 81, plus 2 cubed root of biggest perfect cube. So what I'm doing is I'm looking at my list of perfect cubes, and I'm basically dividing 72 by each number until I find the biggest one that goes into it. So it wasn't 1, it wasn't 8. Oh, it was 8, just kidding. 8 times 9 gives me 72, minus 3 cubed root of, what's the biggest one that goes into 24? 8 again. 8 times 3 is 24, and 8 is my perfect cube. So this is 4 times, what's the cubed root of 27? 3. And then I still have this cubed root in there, and 3 is still in there, so I just took that one out. Plus 2 times, what is the cubed root of 8? I know you're wondering, 2. And then I still have, so this is gone, I still have the cubed root of 9, minus 3 times, again, the cubed root of 8 is 2, so I'm taking that out. And then I still have cubed root of, this is gone, 3 is still in there. Okay, let's simplify a little bit. 4 times 3 I know is 12. Cubed root of 3 plus 2 times 2 is 4. Cubed root of 9 minus 2 times 3, 6. Cubed root of 3. Like terms would be this one and this one. What is 12 cubed root 3's minus 6 cubed root 3's? Well, I'm left with 6 because 12 minus 6 is 6. And I'm going to keep my cubed root of 3 plus 4 cubed root of 9. So some of you have an alert going off. 9 is a perfect square. 9 is a perfect square. It is, but we don't care because we're looking for perfect cubes this time. All right, let us now continue. Letter A, my directions are to multiply. That's all they tell me. If you're missing this parenthesis, go ahead and put it there. My bad. I want to do this squared. And above, I already have the special pattern for this that I would like to use. It's right here, except instead of minus, it's plus. So if this was plus and this is plus, it's the same exact rule. So I'm going to go ahead and square the first term. What is radical 50 squared? Well, I'm going to write it out. Square root of 50 squared. I'm going to switch the pen, that's thinner, plus 2. So this is like my A and this is my B. So I'm right here, 2, the A, radical 50, the B, radical 48, plus B squared, radical 48 squared. You could also just write this as radical 50 plus radical 48 times radical 50 plus radical 48, and then FOIL. It's just a little bit more time consuming because radical 50 squared is 50 plus 2 times 50 times 48 is 2400 plus cancel, square root of 48 squared is just 48. Like terms, 50 plus 48 is 98 plus 2 times, now that 2400 perfect square, I'm going to trust my math just a little bit and just this one time and know that that is 400, which is a perfect square, 20 times 20 times 6. All right, 98 plus 2, what is the square root of 400? 20. So that's gone, times radical 6. So this gives me 98 plus 40 radical 6. Radical, dude. All right. Bam. Now I would love part B if these were the same numbers on the inside, and I realize that they're not, so I cannot use this special pattern. No fear, I can always FOIL. Let's talk about that. So if you were like, oh, I would rather FOIL that one, but I'm not sure how, I'm going to show you how to FOIL this one, and if you want to, you can go back and FOIL that one and see that we get the same answer. And maybe you hate this way with a special pattern. I'm not going to be offended. If it's faster for you to just FOIL, please do. So first term, let's distribute this 4 here, and I get 8, and multiply this here, and I get 4 radical 3, and then I'll multiply this and get negative 2 radical 3, and multiply here, minus radical 9. You're going to look at this and be like, well, that's way easier. And then I get 8. These are like terms. So that's 2 radical 3 minus, what is the square root of 9? 3. Cool. 3 and 8 are like terms. 8 minus 3 is 5. Plus, I still have that 2 radical 3. Blah-dow. There you go. All right, let us see if we can do some rationalization. Don't be so irrational. Okay, rationalize each denominator. So what they're talking about there is you cannot have any radicals whatsoever in the denominators. We've actually done this before in a previous lesson. So if you feel good and you're like, oh yeah, I remember this, go ahead, press pause, and then you can watch me and fast forward to the next problem. But for now, for those that don't remember, we're going to multiply this by its conjugate, which is 1 plus radical 7. You saw these when we were dealing with the i's. 1 plus radical 7, meaning complex numbers. Okay, let's distribute 5 times 1. 5 times radical 7 plus 5 radical 7 over, I want to use a special pattern because it's going to make my life like way easier. So from the back side we had a plus b times a minus b was equal to a squared minus b squared. Well, this is a and b, so this is going to be 1 squared minus radical 7 squared. Okay, the top is what it is. Numerator is going to stay the same. But 1 squared is 1 minus radical 7 squared is just 7. I'm going to keep this numerator the same as is. It's great. And then 1 minus 7 is negative 6. Wonderful. All right, here is your test. Not really a test, so calm down. But I want you to multiply this one by its conjugate right now. Radical 7 minus radical 2. Radical 7 minus radical 2. And then I'm going to have you press pause and do this really by yourself and then check your answer with mine. All right, this is what I got. I multiplied this out. Check everything that I have here from when I FOILed and make sure your numbers matched. If one of these numbers don't match your numbers, that's just probably the one mistake that you maybe made. And then on the denominator, I multiplied these. I got radical 7 squared minus radical 2 squared. And then this 20 breaks down. My perfect square that goes into 20 was 4 times 5, and I pulled out the 2. It feels like I should be able to simplify a little bit more here, but I can't. This is just 7. So 7 minus 2 is 5, and then I just kept all of these the same. And that is my answer. All right, let's do one more together, shall we? Okay, your last example, rationalize the